Hey everyone, this video is for my chemistry students. We're going to do a continuation of chapter 9 and I'm going to get more into the percent composition, see if I can show you some basic ways of getting this done, go over lots of examples. I don't know how long this video is going to be. I don't know how many examples we're going to get through because this is involved stuff. So I'm going to jump right into it and go to example 9.8 on page 233. And it says, a laboratory analysis of an unknown gas has shown that the gas is 72.55% oxygen. And whatever the rest is, that's going to be 27.45%. 27.45% carbon. And they ask, they say, and this is by mass, what is the empirical formula of that compound? In other words, is it CO2? Is it C2O2? Is it CO? Is it carbon monoxide? We don't know, okay? And they've given us our elements in how much they weigh. 75% of the mass is oxygen, 27% of it is carbon. And the first thing we got to do here, and this is just a little trick, change these percents to grams. All right? And it's not saying you have 72 grams of oxygen and 27 grams of carbon, but to figure this out, we could say they're the same ratio. It's by mass. For every 72.55 grams, we'll have 27.55 grams of carbon. I meant to say of oxygen, not this of carbon. And we have to change this into moles. One of the things you have to remember, practically from here on out, we always have to change whatever they give us into moles at some point. So how do I change this into moles of oxygen? Well, from my periodic table, I look at the molar mass, the mass that they have on the periodic table. I know that 1 mole of oxygen weighs 16 grams. I have the grams in the denominator because I want these grams to cross out. And I can do the math there, and I can do 72.55. What did I put my calculator? Oh, well, here's another one. I don't like this one, but I'll use it. 72.55 times 1 divided by 16. And I get that I have 4.53. We'll go on out to 4 places. 4 moles of oxygen. We're going to do it for carbon also. How much does carbon weigh? I didn't look at this ahead of time. Carbon weighs 12.01 grams per mole. So, 27.45 divided by 12.01 gives me 2.2856 moles. Okay, and you go, well, great. So is this my composition? Carbon 2.29 and oxygen 4.53. These must be whole numbers. How do we do that? Well, you guys know, and I hope you know, if I ever have a fraction, I have something like 4/12, and I want to reduce that. I'm going to divide both top and bottom by 4. Same as if I had 12/4. I would divide both numerator and denominator by the smaller, the lesser number. We're going to do the same thing here. I'm going to divide both of these numbers by 2.2856. When I divide 2.2856 divided by 2.2856, I will get 1. That's no problem right there. But when I do this, and I say 4 4.53, let me see here, 4.5344 divided by my answer equals, and I will get 1.983. Well, that is very close. Oh, I'm off the screen. That is very close to 2. So the ratio, the empirical formula, it says for every 2 oxygens, I have 1 carbon. Yes, this is CO2, carbon dioxide. Okay? We're going to do another one. We're going to use the aluminum sulfate that we did in the first few problems the other day in that other video. I don't know if I ever called it aluminum sulfate in that. We found that it was 15.77% aluminum, 28.12% sulfur, 56.11% oxygen. We're just going to take those percents and change them each into grams, and then we're going to multiply, there's my calculator that I like, by these numbers. For aluminum, 1 mole, and I'll abbreviate this one. That's not much of an abbreviation, is it? Just dropping the E. Aluminum weighs 26.98 grams. And 1 mole of sulfur weighs 32.07 grams. And 1 mole of oxygen weighs 16 grams. I'm going to do each of those numbers, and I'm going to get a decimal for each of them. 15.77 divided by 26.98 gives me 0.5845 moles. Okay? We have half a mole of aluminum so far. 28.12 divided by 32.07, and grams cancel in case you didn't catch that. We have close to 9/10 of a mole. We have 0.8768 excuse me, and here, and that's moles of sulfur. I should go ahead and label it. And 56.11 divided by 16 gives me 3.5. We'll call it 507. Well, we went out to 3 decimal places. That's 5069 moles of oxygen. Now, there's the ratio of their moles. We want these to be whole numbers. And as I said earlier, in order to do that, even with fractions or decimals, we're going to divide each of these by the decimal with the least value. I'm going to divide each of them by 0.5845. 0.5845. Of course, this will give me 1 mole of aluminum. Okay? 0.8768. 0.8768 divided by 0.5845 gives me 1.5 moles of sulfur. 3.5069 divided by 0.5845 equals 5.9 repeating. Actually, it comes right, if you do round it even up to, well, 998, yeah, we get 6. It's 5.9998 moles of, what is this, oxygen. Okay? So, they're in a ratio of 1 to 1.5 to 6. We're not allowed to have fractions or decimals. I'm going to multiply each of these by 2, and I will get 2 to 3 times 2 is 12. So it's technically Al2S3O12. Now we don't write it that way because this was an SO4 ion, a sulfate ion. They have it as Al2SO4, and there's 3 of those. But if you put this down as an answer, I would have to accept it. That's perfectly sufficient. We're already past 10 minutes. Let me just, if you look at the top of page 234, or all of page 234 really, example 9.9, in this one they go ahead and give you the masses of each of these elements. They don't tell you their percents. You didn't have to convert percents into grams. They've gone ahead and given you the grams. They convert each of them into the number of moles for each of them. For the nitrogen, they divide it by 14.01 grams of nitrogen per 1 mole of nitrogen. And they come up with those numbers: 0.1316 moles of nitrogen, 0.1973 moles of oxygen. They divide them both by 0.1316, the smaller of the two numbers. And they come up with a ratio of 1 to 1.5, 1 to 1.4999. Okay, that meant for they have 1 mole of nitrogen, 1.5 moles of oxygen. They multiply them both by 2, and they get a 2 to 3 ratio. And you're able to find out the empirical formula. Let's do one more. You know what? I'm not. I'm going to stop there. I'll break this into other videos. I may skip 9, 10, and we'll go on ahead and go on to section 9B in the next one. So watch for that this week. See you guys.